And I would like to invite to the stage Chance Du, who's a project lead at Coefficient Protocol, Raullen Chai, who's the CEO at IoTeX. I want to bring back Mr. Wilcox from ZCash, and John Kisagun, who's the co-founder of Enigma. Thank you.
Hello. It's my pleasure to moderate this panel. I'm the project lead at Coefficient Protocol. We have a booth there. If you want to know more about what we do, you definitely check it out. And I'm honored to here to talk with the most experts in this privacy and security panel. And so let's start with self-introductions. Start with Enigma.
Hi, my name is John. I'm one of the co-founders at Enigma. At Enigma, we're building the first platform for scalable and end-to-end decentralized applications. I'm saying end-to-end decentralized because we don't think that you can have decentralization without privacy. If you think about the applications we use today, almost all of them touch some sort of sensitive data, and it's unacceptable to have those applications live on the blockchain ecosystem. So that's why we're introducing this concept called secret contracts, which are basically smart contracts with hidden inputs that the network doesn't have to see, but you can still compute and reach consensus on. So think of us as Ethereum with data privacy. We're trying to do what ZCash did to Bitcoin transactions, but for more general purpose computations.
Yes, hello, I'm Nathan. I work at ZCash. As I just described, we're focused on creating really strong private transactions on a design like Bitcoin, and our long-term goal is to migrate that system to be pervasively private, so all transactions will be private.
Hi, this is Raullen from IoTeX. We are building this blockchain for IoT. Basically, we're focusing on two things. One is auto scalability, like I just described now in the presentation. Another one is privacy. Definitely, we feel like privacy would be a really key features for IoT blockchain.
Thanks for the very good introduction and give the audience some background of what they do. And let's start with the first questions. Why does privacy matter, and why it is the increasing importance when discussing about blockchain?
Yeah, so I'm going to make a bold claim, and I'm going to say blockchains without privacy are useless because you basically cannot have everything you do publicly available to anyone. I think it's great that more and more people are starting to talk about this. We started our research in 2015 when we started looking into privacy-preserving computation with secure multi-party computation. And yes, we're seeing, like Vitalik talk more about privacy. We're seeing competition coming into the space. So yeah, I think it's a good sign that more mindshare is flowing in this direction.
Why does ZCash think privacy matters?
Well, the typical language we use is that we believe it's a human right, so it's sort of just a value proposition. But there's a lot that goes into that. So, so one thought is if you have a system that has pervasive privacy, it's quite easy for individuals to choose to disclose how they use that system. So you can still have transparency when it makes sense for particular users. Whereas if you are in the other situation where if you have like a platform that has no privacy built in, it's very difficult to build privacy on top of that, especially if not everyone is using that second layer of privacy.
Got it. And I know IoTeX is kind of a specific building a privacy IoT blockchain. So why you think that matters for this IoT industry?
Yeah, because I feel like for IoT, privacy is especially important to think about like all the devices around you. They are constantly watching you, what you're doing, right? Like how much money you own, what you're doing, who you like to talk to, what is your favorite like a shopping behavior. So all these things, like we feel like we should give this user the option to have privacy when it comes to blockchain. So actually the privacy we are working on is like a more broader, is actually a broader concept. So we want to hide all the states on the blockchain to make them like computable, but at the same time private data. Yeah.
Yeah. Thanks for the good answers. And the second question is, we know that Monero is a very good privacy coin, but unfortunately used by a lot of like illegal kind of like transactions. So for the legal perspective, does the emergence of the privacy techniques for blockchain hurt or help this industry more? You think it's hurt or help? The rising of the privacy.
Yeah, so I think in the big picture, it can be harmful because what I would like to see is not only for privacy to be implemented in these new platforms, but actually I would like to see our cultures sort of reestablish privacy as like a fundamental value. So if criminals flock to these tools like early on, I think that's really harmful because people will associate that with these tools. And I think they would be missing the bigger picture.
How do you think about Raullen?
Yeah, I definitely agree with Nathan said. Like privacy should be very important to people's life.
Like building on what Nathan said, like people still think that Bitcoin is a way to buy drugs, whereas we all know that once you do something with Bitcoin, it's visible to everyone. So I think with every technology, there could be different ways it could be used. But I do agree with you that for real adoption, do we have any water? For real adoption of this, we need some privacy. But I also want to like have us think a bit more from a practical perspective as well. So right now, we think about moving most of the applications we use into this ecosystem, but like, and people are trying to decentralize Uber. Like think about a decentralized Uber, right? Everyone knows what wallet you own. Everyone knows which transactions you've made, and everyone knows if you have a rich friend. And then everyone knows where you're getting picked up from, and everyone knows where you're going. So like in a world like this looks more like a kidnapping application to me than just like a going somewhere. So that's why like we really need to integrate these, not just from a legal, but also from a practical perspective.
Thank you. Then next question is, so right now we see a lot of like projects actually targeting the scalability solutions in the blockchain, but actually there's like very few projects actually focus on privacy. Don't you guys think the privacy issue itself is undefined, or it's just because it's very hard to kind of like draft a solution for this? Very few projects actually working on the privacy specifically.
Yeah, I can answer this one. So that's actually a very interesting question. Thanks for asking that. So basically, blockchain has built on top of 3 pillars. I think one is cryptography, one is decentralized distributed system, and one is economy, right? So for decentralized distributed systems, there are multiple like engineers, they will have this experience to work with the system like this, so they will be able to do scalability for blockchain even. But I mean, for privacy, it's mostly should be, you have to have some domain technology, especially in the world of cryptography, like ZCash. It's a very hardcore cryptography. It's not that everyone could work on immediately after reading the code, after reading the paper. It would take some years to thinking, to internalize, before you can actually work on that. So that's why I think there are very few projects that really have these experts on the team who can work on things like this.
Yeah, so what's the most impressive privacy project except ZCash? I asked Nathan.
Well, I mean, the standard go-to for me is Monero, because Monero and ZCash have very similar goals, and they're their designs are roughly the same, like their currency, but their approaches are both very different. And I think where we are at in this whole space is that there's a lot of exploration of design space, and I think we'll learn through trial and error in many cases that some designs work better than others, or some aren't feasible, maybe when we hit a certain scale or things like that. So I think it's better overall for the whole world to have multiple approaches, especially if they're, so like ZCash and Monero do things differently, like on many different axes, like governance, technology, and so on. So I think that's a good thing.
What's the major difference with ZCash and Monero, you think?
And well, I think one of the most important ones is sort of the governance or the community. So, most of the ZCash development right now happens at our company, whereas Monero is a decentralized project with pseudonymous contributors. And I think, yeah, so their approach also is to add privacy to different components, like as soon as something makes sense. So they've combined like multiple things to give a more comprehensive kind of privacy. The ZCash approach technically is to create something that already has all of the privacy guarantees you want, and then try to improve that and increase adoption of that.
Okay, any add-on for this question?
I think around the adoption part is, so when we think about privacy-preserving computations, there are three main methods. One is zero-knowledge proof, which ZCash is pioneering, and then the other two are the homomorphic encryption that everyone talks about, and the secure multi-party computation. And I think there are limitations with these two technologies that do not go hand in hand with the realities of our ecosystem. So with homomorphic encryption, people claim we do it, but we can't really do it in any kind of practical setting. So that's not usable. And then I think MPC, in a way, does not really flow with the fully purist decentralized vision of it, because there's one attack vector which says if everyone colludes, then the data can be revealed. And some people who are very, very purist about it thinks that this is a trust model. So what I'm trying to get to is, I think privacy, leaving Zcash aside, has limitations that make it hard for people to grasp.
I got you. Building privacy into blockchain comes with some trade-off. For example, maybe you know the transparency, which is the most important component in this blockchain. And also, you could argue that it might cause some inefficiency in this industry. What's your taking on this?
Well, we know about the efficiency issues firsthand. And so I think so if you look at our network today, the vast majority of the transactions don't use the privacy technology. So it's about, if you look at a particular time slice, like the past week, it would be about 75% of the transactions are just like Bitcoin transactions. So with, or if you look at the history of Monero, like when they initially deployed, there wasn't like a minimum requirement for something called the mix-in, which higher mix-in gives you more privacy. A mix-in of 1 is no privacy. And so many transactions had no privacy. So I think both of these systems are sort of experimenting with live users by rolling out stronger and stronger privacy to see how they achieve adoption. Also, they're both willing to sort of push their users towards using privacy by default. And I think it's kind of an open question, like if you compare it to Bitcoin, how much does the performance cost of privacy really impact adoption? Or, because it provides benefits, I think it's an open question as to whether or not those benefits will compensate for the trade-offs.
Raullen?
Yeah, so definitely there's a trade-off between how much privacy you want and how much performance degradation you can sacrifice. So we are trying to make this a very sweet. We are trying to hit the sweet point of the trade-off by actually sacrifice some of the privacy, but to achieve a certain degree of privacy. So that's why we call this lightweight privacy preserving technologies that we are working on, because we feel like the IoT devices are usually too weak, like they are constrained in memory, in connection, battery, in computation, storage, everything. So there is actually really hard to implement like a full stack privacy technology like ZK Snark and also MPC. But we are trying to look into something that is relatively lightweight. That's actually my PhD research that I've been doing like for so many years. Is so-called lightweight cryptography. So we are trying. I think the approach we're mostly to take is a Monero kind of approach, confidential transaction. But still, we feel like there are some wiggle rooms. We can make it even like a more lightweight. So, but answering your question, yes, definitely there are some trade-offs between performance and privacy.
Yeah, how do you think about Ken?
I think the trade-off becomes really interesting when we think about some of the use cases that we think that's not like a decentralized Uber, but things that are like very relevant to us today that cannot live or exist without privacy. For example, governance is a big issue. We just had a panel about governance. In the world where everyone knows which way we're voting, whether it's like token-created registries or general governance, you can make bribery contractual. So you can just write a code which would basically pay you depending on your vote, and that's not a way to go about decentralized governance. So for these kind of things, yes, this comes at a cost, but it has to take place.
Got it. There are definitely different techniques for achieving different aspects of the privacy. For example, confidential transactions for hiding the individual transactions, for better anonymity, and the Wimbo for hiding the entire transaction graph, Hook for privacy preserving smart contract, and so on. How practical and effective this approach are, and what is the holy grail, and what is the trend here, you guys think? Different techniques.
I think it's very application specific. It would be hard to say this is holy grail for that. There are things that ZK snarks are great for. There are things that they don't work as well. And then there are things that MPC is great for, but ZK snarks don't. MPC is not that great for. So like I think it's a very application-driven question. So it would be hard to say this is a holy grail and this is not.
Like my personal take of this, like in terms of privacy preserving computation, definitely fully homomorphic would be the holy grail, but it won't come in 10 years, that's my guess. So in the short term, I think MPC is very promising, like given maybe 3 to, I don't know, maybe 4 or 5 years, it should be mature enough for us to use as a privacy preserving computation. But if you want to do this right now at this moment, I feel maybe the only option you can do is SGX, TEE, HSM kind of hardware-relied solution, which could be used right now. But the risk is pretty high, given this is still like an ongoing kind of research in terms of hardware security. Also, this is first generation of such a computable hardware security module. So there might be some security risk. So if you want to use these things, just be careful, but yeah, I think that's maybe one of the practical approach you can take right now.
Any adds on?
Well, I'm mainly only somewhat familiar with zero knowledge proving based approaches, and ZK snarks are zero knowledge proving technology that's for general purpose computation. So I think they currently might be the best kind of solution apart from like hardware security modules for private smart contract features. And once you like narrow down the use case enough to really specific things, there can be much better, more efficient solutions with strong privacy. So like I have been really interested in some of the work done by Andrew Polstra and some others on things like, I think he calls some of his research like scriptless scripts. So in that case, for a few specific kinds of smart contracts, you can boil down the verification to just basically the same cost as like verifying a single signature. So I think if you can cherry pick specific use cases, you can get really good trade-offs. But if you want general purpose computation, you need to use something like ZK snarks.
Okay, got it. So it's kind of like all the approaches is like fall into the cryptographers. There is a lot of way to provide privacy using controlling blockchain or brain transaction computation off-chain. What is your opinion about this? Bring the transaction competition off-chain.
I mean, like, depends. Like, off-chain is a different, because off-chain is a very big umbrella term. Like, it could be off-chain, but it could still like preserve privacy of the data, which I can live with. But if you're like doing a consortium approach and then sharing the data, there is a trust model involved that can work for some applications, may not work for some reason. So I think like it needs to be considered in like more let's say use case specific situation. I'm giving these vague answers, but I think like the holy grail is privacy preserving computations, whether that's ZK snarks or other methods. But I don't like sharing data and trusting the other side with it.
Aizan?
Yeah, actually back to their previous point, I think it will be really useful for some of the applications. For example, maybe some Lightning Network kind of thing, like you can do the payment off-chain and settle on-chain. So it will work for some applications, but not a general purpose solution.
Nathan?
Well, I also think privacy isn't just a monolithic thing. So with any sort of behavior users want to do, they may care about privacy of different aspects. So if you think about like just simpler bilateral state channels, or bilateral payment channels, like as the building block of Lightning, and you imagine just two parties using a payment channel, by looking at the blockchain, you can sort of determine who those two parties are, and so you know they have some relationship, but you may not be able to see each individual payment. So that might be good enough for their particular application. Whereas some other applications, you may want more general privacy, like you don't want who the two participants are even known. So that might happen if you have like a consortium of traders who are trading assets on an exchange. The fact that two traders are like talking to each other is enough information for other traders to respond to that. And so I think like that example sort of illustrates how permissioned blockchains, where you kind of have a club, don't work for like many important use cases. And I think there's one final bit, which is about user education, which is that different approaches can make trade-offs for privacy in specific ways, but it's hard for users to understand that. So I think the goal should be to make as much about their behavior with the technology private as possible, so that just so that they're not surprised and they don't have to like study, okay, if I'm using Lightning, which details become known to third parties and which don't, versus Monero or ZCash. Like the ideal is that they just use something and it protects them as much as possible.
Okay. So among all the use cases for blockchain, identity is one of the most intriguing problems. And recently, breaches in the misuse case consumers' data are driving individuals to demand better protection of their personal data. How do you think privacy on the blockchain could help these problems, like identity for the consumer data? Those kind of privacy could help.
Yeah, again, I think this boils down to the privacy-preserving computation we were talking about. So ideally, like people can store the data in a private way somehow and put it on the blockchain. Then everybody else can just use this piece of data for verify if this is a real person, if this is a real identity of this guy, right? But given this like a homomorphic encryption or even like MPC security modules, they are not perfect solutions so far. So this kind of ideal application doesn't exist as of today. So that's why there are some like maybe simplified applications. For example, Civic, they basically store your identities on your phone and they just anchor the hash on the blockchain. Then you can just, later you can just use this hash to check his ID. So that's kind of very simple identity solutions. But as the privacy technology goes forward, I can see like even more advanced, also interesting applications for identity management down the road. Yeah.
How do the Enigma?
Yeah, I think one thing that's very interesting is we always think about how to move identity as we know into the blockchain world, which is exactly, you have to store it somewhere else, maybe locally, and then selectively share information, maybe using like zero knowledge, saying I'm older than 21 rather than sharing how old you are. But I think what's very interesting, and I think we should talk more about, is through the blockchain, we're creating an operational reputation. Whether this is our transactions, whether this is the smart contracts that we participate in, or like with staking, like how reliable we are, like all these things become metrics to measure how reliable we are. And I'm guessing that we all use multiple different addresses for multiple different things that we do. So I think one thing that's going to be very interesting is how do you get to claim that you own certain addresses and have a certain history without revealing who you are and what you own? I think that's going to become a very, very interesting question. I'm personally very excited about that.
Don't you think the future of kind of like identity direction is go to kind of like a drive into the anonymity, or just you know, maybe more what right now, like where Facebook's works, like it's kind of like everybody's transparency their identity online, or maybe in the future on the blockchain. So which direction you think our industry heading to?
I mean, I would hope to see like in a like, you know, Facebook not screw with our data, but like it's really impossible to have Facebook on a decentralized ecosystem as is, right? For that, you need to have a lot of like private computations. Otherwise, everything you do is visible to everyone regardless. But I think a lot of what's going to happen is, I mean, there's, I think the Web3 Foundation has created this DID specs, how you store certain information in local devices or like off-chain and then be able to selectively share it. I think that's an interesting trend. There are still like holes to be filled, but that's how I see the industry will go.
Okay, so next question is, how do you promote privacy on blockchain, and how should we educate the mass the importance of the privacy in blockchain? And for listen, you think ZCash is gonna be the major kind of like coins or blockchains used by a lot of like maybe enterprise or developers, you know, create some like very mass adopted apps? How do you think about this?
I didn't quite understand the second part of
The question is like how to promote privacy on blockchain. So like educate them, is it important?
Right. So I think a good strategy is to educate the designers of blockchains right now that privacy should be one of their key design goals. Yeah, we were talking earlier, and I was pointing out that privacy is, a lot of people kind of focus on themselves or an individual when they're thinking about privacy, but privacy is actually kind of a system-wide phenomenon. It's sort of like a public good. If there's a system that has strong privacy and people are using it, they are protecting other people just by the fact that they're using the privacy mechanism. Not having privacy works initially until it doesn't. So I was thinking about this analogy where having a lack of privacy is sort of like being vulnerable to an epidemic or a disease, and privacy mechanisms can be sort of like a vaccine. So vaccines are only useful if enough people use them. If only like one person uses the vaccine, it doesn't really help much. And so you can have systems like Facebook that work and everyone loves them and many people use them, and then one day everyone realizes there's this systemic problem and it's been designed this way and it's like really difficult to solve now. So if you're designing a new system, you have a chance to prevent that sort of long-term system-wide failure.
What do you think about Raullen?
Yeah, I think privacy and security actually they share the same problem. Like they are both very important, but they are trying to make people's life harder because it's hard to use. Like you give more restriction on the things, right? So that's why I'm thinking maybe some of the research or even maybe industry effort should be really focused on the user experience of security and the privacy. So instead of like educating users how important they are, actually you give some like a very good experience to encourage them to use it. For example, like vaccine example, right? Vaccine is so simple. You just sit in there, someone just inject, then it's done, like just 1 minute. If user experience for privacy and security could be in this way, I think maybe more and more people will like it.
Okay, any other topic you want to add on this question?
No, I don't have much to add, but I think like one thing that's important is like we all care about data security, but we think, or in most cases, people consider privacy to be a nice to have. But if you think about it, privacy is data security, and I think our overall general approach to privacy should change, and I think that's a way to spark this this education or like the understanding of the importance of privacy.
And any other topics you guys think we would like to talk about to wrapping up this panel for privacy? Other topics you think it's interesting to talk about right now?
Well, there's one that I don't necessarily know too much about, but it's regulation. Yeah. So it's really interesting to see different like regulators in different jurisdictions approaching this differently. So, for example, I've heard about all privacy coins sort of being banned in Japan. Whereas by contrast, like Gemini recently announced listing new coins, including ZCash. And so the regulator, the NYDFS, explicitly said in their statement that ZCash provides privacy and that can protect consumers. So it's an example of a regulator realizing privacy is important to protect consumers because that's part of their mandate. And if you look at like the GDPR regulation in Europe, you see that some jurisdictions want to promote privacy with regulation. I personally have I've never felt like I understand regulation well enough or know how to predict like where it's going, so I'm more of a technologist. But I would like to see the technology and the regulation both going in the same direction, in the right direction towards better privacy to protect people.
That's actually interesting. I didn't know the Japan thing, but I think GDPR is like ethos-wise is very promising in that it cares about our privacy and us as users getting control over our own data. But unfortunately, the way it's been written is it's written for decentralized systems. So I think what's very interesting. So technically speaking, you're not supposed to store anything, even if it's encrypted, on a public ledger, because encrypted information, according to GDPR, is still personal information and cannot be shared. So like that opens a whole lot of questions where if I'm able to download my data from Google and then share it, do I become the owner of my data? And if I share it as an individual, am I responsible? So I think like it's interesting to see how it's going to evolve, but I think it's good that that we have some sort of regulation, even if it's just from a directional perspective that pushes for privacy.
Right. I didn't mean to imply that regulators or legislators get it right, for sure. But so I actually think this is really important for technologists to build things that work well and protect users as like an education tool for regulators. So when they're like drafting a policy or legislation, and like policy analysts can say, well, that would prevent like this private blockchain from operating, but it's already operating and people are using it and it's valuable and it protects them, then that can help them avoid making some of those silly mistakes.
So what's your favorite topic in privacy?
What do you mean favorite topic?
Like in this privacy space, you think what's your exciting, topic you think?
I focus a lot on the applications on the Ethereum ecosystem that would require privacy. I just spoke about voting. That's something I think is very important to the ecosystem. We're trying to figure out more of the what we call building blocks that would be usable by a variety of applications. I think the promise of like being able to do decentralized, like revolutionary AI is very, very interesting. But I think we're very, very far away from it. So to me, it's interesting to think what I can cater to the Ethereum ecosystem that can just create adoption immediately. And those are usually like like more building block level things rather than earth-changing ideas.
Raullen, do you have any
Sure. I think instead of actually, in addition to privacy, security is also important. Given like we are seeing lots of 51% attacks against the different blockchains, so which is a very interesting topic actually. I saw there's a website that actually lists out all the POW blockchains and how much money you have to spend to 51% attacks these blockchains. So this means like when people trying to promote blockchain technology, they really forgot maybe some basic principles about how to make the blockchain secure and why should we make the blockchain secure. So that's probably also the thing I think like industry and academia should be focused on too.
Okay, so we have 5 minutes open. 2 questions to audience.
Yeah, this is the first time I've heard such broad and general discussion of multi-party and homomorphic cryptography in the context of blockchain. And I was kind of wondering, well, first of all, I think there's like a lot of dots to connect between, going from where we are now into, where I'm assuming you want to go. But just to clarify specifically on that, can I hear, I guess, exactly how that is supposed to fit into a transaction of value type system? Because it seems like you're saying that everybody has their own data, and then you have this like communication cost and things like that between all the billions of people holding their own wallets and things like that. So I guess I didn't quite understand exactly how homomorphic and multi-party computation is supposed to lead to the types of systems that, like, let's say Bitcoin.
So like one thing, like I'm going to talk about multi-party computation. Like one thing that you could do with multi-party computation that, I mean, I don't think we should just think about transactions, but like in its nature, multi-party computation enables multiple parties to involve. And the way that happens is you distribute data among multiple nodes, and then those nodes can bring that data together within certain conditions. So like this could be something very interesting to build, like a multi-sig that functions across all basically wallets, because what you're distributing is your key. So like that's the way to think about it. In terms of the second part of your question, like what are you exactly referring to as like transaction of value?
Well, I mean, I assume that you're talking about some type of distributed ledger, and you want to say, like, I understand how a ZK snark is sort of proving that a transaction happened and it put value into a certain wallet or something like that. But in the case of multi-party computation or homomorphic, you're saying that we can provide privacy somehow, and I guess I just want to hear more about how those dots are connected in kind of like, let's say, an example system that is practical for a large number of users.
So I think like an example, and I don't want to dominate this answer, but like to see how the two are different is, I can use ZK snarks to prove to you something I know. Let's say my age. I can prove to you I'm older than a certain age. But if you want to find out who in this crowd or panel is the oldest without anyone revealing their ages to anyone, then you cannot do that with zero knowledge. You have to use something like a multi-party computation. And I think that's where the application-wise differences come into play.
Oh, more questions? Okay, just any questions in terms of security or privacy?
Any thoughts on when there will be a viable public blockchain that does not require a trusted setup? A practical one?
Any thoughts on when?
When, yes.
It's difficult to predict. I know that so there's this company, Starkware, that the Zcash company is affiliated with. So one of the Zcash company founders or actually a couple, have founded Starkware. And so that's based on research for a different kind of proving technology that doesn't have the setup parameter, but it's general purpose computation proving, which is a little bit different than like bullet proofs or scriptless scripts, which are more not general purpose. But then there's these other options like bulletproofs, scriptless scripts, and a host of other zero-knowledge proving technologies that make different trade-offs, so they're not good for general purpose applications. Or in the case of Starks right now, I think the proof size if we wanted to like just switch Zcash with basically the current transaction semantics and design into Starks, then I think the proofs would be much larger. So Zcash proofs are like 200 bytes. Starks might be, I don't know, hundreds of kilobytes. But there's a bunch of different knobs for trade-offs. So one thing Starks can do that's quite interesting is if you want to prove something that's extremely large, like many inputs, like let's say blocks filled with transactions, so maybe a gigabyte large block, then it has a payoff where the proof size grows sublinearly. So then you might be able to create a practical system based on that. So I feel like it's on the order of a year or years.
Okay, thanks for this great panelists, Raullen and Nathan and Ken, and hope you guys enjoyed. Thank you.